Hello everyone, myself Deekshit and today I'm going to talk about computer architecture and trends in processor design. Today I will specifically be speaking about processor design. This is an important topic because it determines the future of computing and influences the areas of application including artificial intelligence and machine learning. Let's start with the introduction. Throughout this lecture, I will be delve into the design trends of today as well as historical events that have shaped these trends. We will touch on the shift and single core to multi core design, which has drastically enhanced the performance and impacted software development methodologies. We will also emphasize the role played by energy efficiency in green computing, which is critical for ensuring the future computational needs are met. So, what is computer architecture? Basically, computer architecture specifies the physical and logical design of a computer system. It determines how hardware and software communicate, such as the organization of CPU and input and output devices, memory. Knowledge of these interactions is critical to create effective system that satisfy the requirements of modern application like multi-core computing real-time systems. What are the importance of computer architecture? A strong computer architecture is a key to innovation. It allows the creation of sophisticated technologies such as artificial intelligence and machine learning. As applications become more sophisticated, the required for scalable and flexible architecture becomes more critical. These flexibilities help systems handle different workloads efficiently, providing consistent performance while reducing power usage. Let's go back to the history. Looking back in 1980s, computers got a lot faster thanks to the new technologies in this generation. Then in 1990s, they started doing many things at once by using parallel processing. That's basically multitasking for computers, which led today's processor with multiple cores, like having a lot of workers on a single project. These are the following of some important trends that define processor design in recent time. Multi-core and many-core processors enabling great performance through simultaneous execution of many things. Instruction-level parallelism methods that enable the execution of multiple instructions concurrently. Energy efficiency, which is a critical to minimize power usage. Specialized processing units such as GPUs and for specific purposes and many more. Now, let's talk about the transition from single core to multi-core processor. This paradigm has transformed processing power and overcome issues like thermal limitation and power dissipation. Using multiple cores, the system can process more data throughout the complicated calculation more effectively. As a result, software programs are being adapted to multi-core environments, creating new generation and performance respectively. This is this is the difference between the multi-core and the single-core MCUs. Now let's look into the multi-core architecture, the popular multi-core architecture. These are the modern day examples of multi-core processor. Intel Core series and AMD Ryzen series. Intel Core series used extensively in desktops and laptops with core counts ranging from dual core to 18 core versions. The highlight features include hyperthreading for enhancement, multitasking, and turbo boost for real clock times. AMD Ryzen series, renowned for excellent multi-core threads performed with core counts varying between 4 to 16. It focuses on effectively on IPC increments via its Zen architecture. Next, we'll discuss the impact of Moore's law. Moore's law states that the number of transistors on a microchip doubles approximately every 2 years, leading to increased performance and reduced cost. However, the slowing of this trend poses challenges for future innovation in processor design. It is essential to address challenges to continue advancing technologies. Now, let's look into the energy efficiency in processor. Energy efficiency processor help deliver better system-wide performance through the ability to compute more per watt. This specifically valuable for data centers, where the power costs have a major influence on operational expenses. Methods such as dynamic voltage scaling and low power states enable process to execute well under changing workloads while satisfying sustainability objectives. Techniques for energy efficiency. There are many techniques. Some are along with the voltage adjustment processor also have clear methods such as disabling parts being used or workload scheduling management so less power first goes bare into light tasks. These approaches minimize wasted energy without dimensioning performance. Thermal management. High performance processor generate a lot of heat, which needs to be managed to keep the processor reliable. Typical cooling methods include air cooling and liquid cooling. Advanced cooling techniques like microchannel cooling use tiny channels with fluid flowing close to the hotspots to remove the heat. Further methods may even mimic natural systems to efficiently regulate temperatures. These are the several techniques used in cooling the processes. Now, let's look into the future solutions in cooling. Scientists have developed bio-inspired cooling methods such as replicate how animals cool their bodies. They have even examined special materials that transfer and release heat and face challenges to cool processor. These developments may make the processor of the future both powerful and long-lasting. Rise of AI accelerators. AI accelerators are custom processors optimized to speed up artificial intelligence and machine learning. They involve a lot of parallel computing and specialized architectures such as symbolic arrays to perform large math operations effectively. There are many points where the AI accelerators are used. Specialization, parallel processing, and energy efficiency are some of the points where AI accelerators follow. Now, let's look into the case study of the processor which was done recently. For instance, NVIDIA Tensor Core is their graphic processing units are AI scientific. They have capability to perform mixed precision calculation extremely fast, which speed up training of deep learning methods employed in applications such as the speech recognition. This technology is a wonderful illustration of specialized processor facing AI process. Now let's talk about emerging processor technologies. Chiplets and modular design. Chiplets are mini chips complicated to create a large processor. Modular construction makes it easier to scale and customize the lowers production cost. Rather than producing one numerous chip, companies construct and test individual chiplets and then assemble them. This makes processor more flexible. The emerging technologies 3D stacking and packing. 3D stacking stacks chips on top of each other rather than side by side. It conserves space and decreases the distance data travel within the chip, which makes it more speed and easier to transport the data. Now let's talk about the processor design predictions. In the near future, processor will combine various types of cores optimized for tasks a phenomenal. known as heterogeneous computing. For instance, some cores could be for AI work and other small processing. This will enhance efficiency and enable technologies such as edge computing, where processing occurs closer to where data originates to minimize delays. Importance for researchers, developers, and industry. These trends are thrilling as they bring new opportunities for researchers to crack challenging issues for developers to create faster, smarter applications. Diverse industries ranging from healthcare to finance will gain by increasing productivity and develop new innovative products. Now, I conclude my project with a quote by Alan Kay. The best way to predict the future is to invest it. Looking ahead, the advancement in computer architecture and processors are leading to better, brighter future that we can all be part of. With this, I conclude my project. Thank you very much.